ma'am.
Okay. You can let us know whenever you feel like saying something, you want to talk. You can just always let us know.
Yes, ma'am.
Okay, Hamna has come. Okay, so everybody is here. Please unmute your mic, all of you. Yes.
Good evening, ma'am.
Yeah, good evening. Miraj, where are you?
Good evening, ma'am.
Good evening. All right. So in the last class, we started the new chapter that is called Quadrilateral, and I just gave you a brief introduction of what is a quadrilateral and some other figures also, right?
Yes,
So
ma'am.
let us quickly revise. We studied about various figures. So one was the trapezium, and so have you noted all these definitions in your copy?
Yes,
Yes,
ma'am.
ma'am.
Okay, so one pair of opposite sides are parallel. Then a parallelogram means both pair of opposite sides are parallel. And okay, just you have already written. So today we will only do the examples and the theorems. So from the next class, we will go to the exercise because it is important, first of all, to understand the theorems and then only you can apply it for the exercise, right?
Yes,
Yes.
ma'am.
Okay, so you have studied various figures. So we will start with a parallelogram first of all, and we will study the various properties of a parallelogram. Okay, like we have studied in the case of triangles. So there were many properties that the angle sum is 360 degree, the exterior angle is equal to sum of opposite interior angle, etc., right? Then various theorems, alternate angle theorem. No, that was not for triangle. That was basically in the chapter of lines. But okay, anyway, so now we will study the properties of parallelogram. So this is a parallelogram. That means opposite sides are parallel to each other, right? So AB is parallel to CD and BC is parallel to AD. So this figure is called a parallelogram, right? Okay, so you write the first theorem. I'm not writing. We will do it here only. So theorem 8.1. What does it say? Please write the statement in your copy, all of you. The diagonal of a parallelogram divides it into two congruent triangles. Write this line. Theorem number 1. Written?
No, ma'am.
Quickly write. Okay, so it says that the diagonal of a parallelogram divides it into two congruent triangles. So here's the figure. So what is given to you? That ABCD is a parallelogram. So it is already given that it is a parallelogram. Remember, as in the case of lines, we saw that it is already given that the lines are parallel and somewhere it is not given that the lines are parallel. So here it is already given that it is a parallelogram, which is an important information. Okay. So you have to show that it divides it into two congruent triangles. So basically you have to prove that this triangle is congruent to this triangle, right?
Yes.
So to show that triangle ABC is congruent to triangle CDA. And also note one important thing here. If I'm using A first, then for the second triangle, I'm starting with C, not with A, right? Please see the figure carefully. So they are congruent. So I cannot write the second triangle as ADC. That will be wrong. Fine. Is this point clear to all of you?
Yes, ma'am.
Ma'am.
Yeah. So if I'm starting with A for the first triangle, I have to start from C for the other triangle because it's congruent that way, not the other way. Okay. So let us try to show that they are congruent. So that is easy. See the two triangles. So it is already given that ABCD is a parallelogram. Okay, let's do the solution, no proof, whatever. So it is given that CD is parallel to AB. Fine. So
Yes,
when these two lines are parallel, that means alternate angles are equal. So if this is my angle 1 and this is my angle 2, so this implies that angle 1 is equal to angle 2, right?
yes, ma'am.
Alternate interior angles, right, Miraj?
Ma'am.
Okay. Now similarly, again ABCD is a parallelogram, so that means AD is parallel to BC, which is given, right? This is
Yes.
given. So when these two sides are parallel, I mean this one and this one, so that means, and this is a transversal, AC is a transversal, so this time the angle 3 is going to be equal to angle 4, right?
Yes.
Yes.
Yes, ma'am.
Again, alternate interior angles. Fine. So now see the two triangles. So in triangle ABC and triangle CDA, right? So now we have angle 1 is equal to angle 2. Then angle 3 is equal to angle 4. And one side is common. Which is common side?
Ma'am, is AC.
AC. AC is equal to AC, which is common. So by which criteria? Angle, side. AAS criteria, the two triangles are congruent. I'm just writing here. So triangle ABC is congruent to triangle CDA. Fine. Please let me know when you are done.
Done.
Okay, let's move to theorem number 2. Now, what does it say? Write the statement first of all, theorem 8.2. So it says that in a parallelogram, opposite sides are equal. Write this, then we will show it. Written?
Yes, ma'am.
Okay. Okay, let's show this one. So again, you have a triangle, parallelogram. This is your parallelogram. A, B, C, and D. All right. And AC is a diagonal. So what is the statement? That in a parallelogram, opposite angles are equal. So what we have to show that, wait, what is given? That ABCD is a parallelogram. All right. So this implies that AB is parallel to CD. This is already given. And AD is parallel to BC. This is also already given, right? Now you have to show that opposite sides are equal. That means you have to show that AB is equal to CD and AD is equal to BC. Isn't it?
Yes, ma'am.
Yes.
Okay. Proof. Now, can I write straightforward that triangle ABC is congruent to triangle CDA? Can I write it?
Yes, ma'am.
Why can I write it? Because this is one of the theorem. We have just proved it, isn't it? The theorem number 1, we have already proved that the diagonal divides it into two congruent triangles. So we don't have to prove it again. We are using the theorem straightforward. So we can write, here we will write the statement, the diagonal divides a parallelogram into two congruent triangles. So this is the theorem we are using here. Some noise is coming from someone's side. Some TV is playing in the background. Okay. Right? Why are you not speaking?
Yes, ma'am.
Yes,
Okay.
ma'am.
So this is the theorem we have used, the theorem number 1. Now, since the triangles are congruent, so can we write by CPCT? Sides are equal, isn't it?
Yes, ma'am.
By CPCT, AB is equal to CD and BC is equal to AD. This is what we were supposed to prove. So far we have seen two properties of a parallelogram. First is that the diagonal of a parallelogram divides it into two congruent triangle, right? Property number 1. Okay.
Yes, ma'am.
Yes, ma'am.
Property number 2 is that opposite sides are equal. So AB is always equal to CD and AD is always equal to BC. So opposite sides of a parallelogram are equal. This is the second property. Now let's see the third property, which is the converse of second property itself. Remember it? We have done the converse theorem also earlier in the chapter of triangles and in the chapter of lines, isn't it? Yeah, someone, I think some TV is playing in the background. Please mute your mic. Miraj, is this you? Okay, fine now. Now, theorem number 3, write the statement. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. First you write, then I'll explain. Okay, written?
No, ma'am.
Okay, so this is the theorem. This is the figure. You also draw it and mark these angles. Let this be angle 1. This is your angle 2. And this is your angle 3. And this is your angle 4. And then I'm going to do it. Draw the figure quickly, all of you. Okay, now stop writing. Look carefully. We are again going to the theorem number 8.2. Now see, one important thing. It is starting in a parallelogram. So that means it is already given that it is a parallelogram, isn't it?
Ma'am.
Yes. Now the next theorem is the converse of it. So it is not given that ABCD is a parallelogram, but it is given that the opposite sides are equal. And we have to prove that it is a parallelogram. So do you remember the corresponding angle theorem?
Yes, ma'am.
Yes. So there was a corresponding angle theorem and there was a converse of it. So in the first case, it was given that the two lines are parallel and therefore the corresponding angles are equal. In the second case, it is given that the corresponding angles are equal and then therefore the lines are parallel. Fine. Similarly here, if it is a given, if it is given that it is a parallelogram, then opposite sides are equal, right? And the converse is that it is given that the opposite sides are equal and therefore it is a parallelogram. All right? Is the point clear?
Yes.
Okay. So next theorem is the converse of the previous one. So in this case, it is given that if each pair of opposite sides of a quadrilateral is equal, so that means it is given that AB is equal to CD. It is already given. It is also given that AD is equal to BC. So this is also already given. You have to show or you have to prove that ABCD is a parallelogram. This time you have to prove. Okay, I'm doing the proof here. So proof. First is draw diagonal AC. So we are drawing a diagonal AC. All right. Okay. Now, straightforward, can I write that triangle ABC is congruent to triangle CDA? Can I write it?
Yes, ma'am.
Which theorem is this? Mridula, which theorem is this?
Ma'am.
Yes, which theorem I have used here? Here. Why I have written that the two triangles are congruent?
Ma'am.
Go
Ma'am,
back to the theorem.
because their sides and angles are equal and
No. Look carefully. It is only given that the opposite sides are equal. Okay. We have to show it is a parallelogram. Now I've
And
drawn
second theorem.
theorem number 1, not the second one. 8.1. We have just proved that the diagonal divides a parallelogram into two congruent triangles. Yes?
yes,
Yes.
ma'am.
Yes, Hamna?
Yes, ma'am.
Yeah, so because it is a diagonal, see, I'm writing a very important thing, that draw diagonal AC. I'm writing it so that I can use this theorem. So therefore, I'm using the theorem. The diagonal divides a parallelogram into two congruent triangles. Right?
Yes, ma'am.
So there are two ways to do here. Either you can use the theorem directly or you first show that the triangles are congruent. That also you can do. See? This is your like method number 1. Okay, I'm calling it my method number 1. I'm using the method number 2 now. You can do either of them. So take the triangle in triangle ABC and triangle ADC. So in case you don't remember the theorem, you can first prove that they are congruent. All right?
Yes, ma'am.
Okay, so let us try to prove. So it is given that AB is equal to CD, which is given. Okay. Now it is given that AD is equal to BC. This is also given. One side is common. You can see AC is equal to AC, right? Which is common. So which criteria? SSS criteria. All three sides. These two triangles are congruent. ABC is congruent to triangle ADC. So both ways you can prove that the triangles are congruent, either by the theorem directly or you can just show that they are congruent. Okay?
Yes, ma'am.
Okay. So first write till here, then I'll proceed. It's not complete yet. Done? You can note down both the methods, okay? In your copy, write it method number 1 or you can write it method number 2. So any method you can use.
Okay.
So the point is actually to prove that the two triangles are congruent. Okay.
Yes, ma'am.
Okay. So far we have proved that the triangles are congruent. First thing. Now we have to show that it is a parallelogram. ABCD is a parallelogram. So what we will do here is now since the triangles are congruent, can we say by CPCT angle 1 is equal to angle 2? Yes?
Yes.
Okay. So now look in the figure carefully. AB and CD are two lines, okay? And AC is a transversal which is cutting them, isn't it?
Yes, ma'am.
And you have angle 1 is equal to angle 2. So which type of angle they are?
Ma'am, alternate interior angle.
Alternate interior angles. So can we use the converse of alternate interior angles here? What does it say? What is the converse of alternate interior angle theorem? We have just completed the chapter of parallel lines, right? Miraj, what is the converse of alternate angle theorem? Miridula, what is the converse? I've spent so many days on the chapter. I did each and every question, each and every example, I think I did. And you're not even telling me what is the converse of alternate angle theorem. Great.
Ma'am, they both are equal.
They both are equal, that is fine. But I'm asking what is the converse of alternate angle theorem? Can you give me the statement? This I have shown by CPCT that angle 1 is equal to angle 2. Now what? Alternate angles are equal. Then now what? Wow, great. So who will tell me? Hamna, will you tell me? Okay, now stop writing, all of you. Please stop writing. Unmute your mic and talk to me. Now, we in the earlier chapter of parallel lines, we did various theorems. Now listen to me very carefully, all of you. Okay, so there were many theorems. One is the corresponding angle theorem, right?
Yes, ma'am.
Then we have alternate angle theorem, right?
Yes, ma'am.
The third one is that the co-interior angles are what supplementary, isn't it?
Yes.
Yes, ma'am.
Okay, and also all yeah, there were others. So if we look at the corresponding angle theorem and the alternate angle theorem, okay, so basically it says that now if two lines are parallel, then the corresponding angles are equal. Fine?
Yes,
Fine.
ma'am.
Yes.
Yeah, if two lines are parallel, So that means it is given that the lines are parallel, and it implies that the corresponding angles are equal. Okay. Now
Okay.
do just the reverse of this. It is given that the corresponding angles are equal, and it implies that the lines are parallel. Okay.
Yes, ma'am.
So basically it is called the converse of corresponding angle theorem. Okay. Similarly, for alternate angle theorem, so one thing is that it is given that the lines are parallel. So therefore alternate angles are equal. Okay. Now it's converse. It is given that the alternate angles are equal, and therefore the lines are parallel. Okay.
Yes.
Remember all of you?
Yes, ma'am.
So this time you have alternate angles equals. What does it mean? That the lines are parallel, isn't it?
Yes, ma'am.
Yes.
Yes. Please speak up, all of you. Say loudly, yes.
Yes, ma'am.
So this time I have proved that the alternate angles are equal. So therefore I can write that AB is parallel to CD in converse of alternate angle theorem. Fine. Remember all of you now?
Yes,
Yes.
ma'am.
Yes, ma'am.
Okay. Now again, by CPCT, similarly, or you can write similarly. By CPCT, now look at this figure. Now AD and CB are two line segments. Okay. And again, AC is a transversal which is cutting. Sorry, by CPCT, first of all, write that angle 3 is equal to angle 4. All right. Now again, use the converse of alternate angle theorem. So this time, see the figure like this. This is one line. Okay. This is another line. Okay. And
Yes,
you
ma'am.
have a transversal cutting them. And this angle is equal to this angle. So therefore, this line is parallel to this line, isn't it?
Yes, ma'am.
Yes. So therefore, AD is parallel to BC. So now this side is parallel to this and this side is parallel to this. So it implies, and therefore, or you can write since AB is parallel to CD and BC is parallel to AD. Therefore, ABCD is a parallelogram. ABCD is a parallelogram. Is this okay?
Yes, ma'am.
See, if you will not remember the theorems, how will you solve the questions? Tell me one thing. Your exams are coming. You have already told me to start new chapters, and you are not even able to remember what I have already taught you. What will you write in your exams? You will not be able to do a single question from the chapter triangles and lines. This will not work. Tomorrow, or I mean in the next class, okay, there's a change. So I'll take your class on Monday after your science class. Okay.
Yes, ma'am.
And we will not have the class on Saturday. All right.
Okay,
Yes,
ma'am.
ma'am.
So Saturday there is no class. The next class will be on Monday after your science class. That means 9:30 to 10:30 India time. In the next class, you will revise all the theorems from the chapter lines and triangles. Lines and angles, and the next one, triangle also. Fine.
Yes, ma'am.
And I'll ask anybody, I'll ask randomly. You will have to tell me. Yes, Miraj?
Yes, ma'am.
Because your exams are already coming, at least revise what you have already learned. There's no need to start a new chapter if you are not able to remember the earlier one.
Yes, ma'am.
Okay. I think enough scolding for today. All right, let's move to the next theorem. See, sometimes your teacher also feel bad that I'm like trying my best to make you understand. I'm explaining each figure, so I messed up all my figure just because of you, isn't it? I try to explain you every point very clearly. I discuss every point 3, 4 times so that it becomes clear to you. And again, you are sitting blank. So that's why I feel bad sometimes. Okay. Now, theorem number 8.4. In a parallelogram, opposite angles are equal. So one theorem was opposite sides are equal. All right. The next theorem, opposite angles are equal. Okay. So its proof is not required in your book. You just remember this theorem. So write the statement and you have to remember that in a parallelogram, opposite angles are equal. Please write it. Okay. Now, next theorem 8.5 is the converse of this theorem only. So this time it is already given that if in a quadrilateral, each pair of opposite angles are equal. So it is given that the opposite angles are equal and therefore it implies that it is a parallelogram. All right.
Yes, ma'am.
So,
Yes, ma'am.
okay. So you please write this also, theorem number 8.5. So this proof is also not required. You just have to remember this theorem that opposite angles are equal, and the converse is also true that if opposite angles are equal, then it is a parallelogram. Okay, written?
Yes, ma'am.
All right, let's proceed. Next is your theorem number. Yeah, just wait for it. It's not responding. Just a minute. Okay, read the statement of theorem 8.7, all of you. Mridula, you please read it louder.
Ma'am, 8.5.
8.7.
Ma'am, if the diagonal of a quadrilateral bisect each other, then it is a parallelogram.
Oh, sorry, we are on 8.6 now. Okay. Sorry, I missed the 8.6. Let's do the 8.6 also. Okay, its proof is also not required, but it says that the diagonals of a parallelogram bisect each other. Okay, please remember, it is very important that if ABCD is a parallelogram, try to understand this thing. So it is given that it is a parallelogram, then the diagonals bisect each other, means they cut each other into two equal parts. Okay,
Yes,
so
ma'am.
that means this side AO is equal to OC, fine, and OD is equal to OB. So they bisect each other. Okay.
Yes, ma'am.
Okay. Now the next theorem is exactly the converse of this theorem. First one, this theorem 8.7 is the converse of this. So if it is given that the diagonals bisect each other, therefore it is a parallelogram. Okay.
Yes, ma'am.
So it is given that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So we will do the proof. Please write 8.7. This we will do. Its proof can be asked in your exam also. Okay, let's do it. Have you written, all of you?
Yes, ma'am.
Okay, so this is the figure. I'm marking some angles. If this is angle 1 and this is your angle 2, please mark them also. This is angle 3 and this is, this one is your angle 4. So what is given to you here? For this, I'm doing theorem number 8.7, okay? So it is not given that it is a parallelogram that you have to prove, but it is given that the diagonals bisect each other. That means, okay, it is given that AO is equal to CO. Fine. BO is equal to BO. This is already given. And what you have to prove, that ABCD is a parallelogram. So this means you have to show that AB is parallel to CD and AD is parallel to BC. So basically this you have to show. Okay, let's do the proof. Okay. So first we will try to do, we will use these two triangles here. AOB, I mean this triangle, AOB, all right? And triangle COD. So I'm using these two triangles and I'll try to prove them congruent. Okay?
Okay, ma'am.
Okay. So in triangle AOB and triangle COD. Yes, Miraj? Okay, now Miraj will tell me what can I use in these two triangles. Miraj, where are you?
Yes, ma'am.
Please. Yes. Okay. So tell me how can you show them congruent? Tell me one thing at least. Look at the two yellow triangles. Tell me one condition.
Angle AOB is congruent to
Congruent. Congruent
angle COD.
is equal. Yes, not congruent. Okay. So basically you are telling me this angle and this angle, right?
Yes.
Okay. Let me call it angle X and angle Y. Okay. So angle X is equal to angle Y. Fine. Why? Which criteria, which
Vertically
condition?
opposite angles.
Good. Vertically opposite angles. Okay. Hamna, tell me the next one. Next criteria.
Ma'am, line AO is parallel to line CO.
Parallel you have to prove. To prove. What is given?
Sorry, ma'am.
Use
Equal.
what is given. Yes. So AO is equal to CO. This is given. CO, sorry. Yes, Mridula, tell me the next one.
Ma'am, BO is equal to BO. Ma'am,
BO,
BD. Ma'am, BD is equal to BD.
BD is equal to BD. No. This side, this much is a part of this triangle and this much is a part of this triangle. So how can it be common? They are equal. Use this
Ma'am,
condition.
ma'am, DO is equal to BO.
Exactly. So BO is equal to DO. Can I write it like this?
Yes, ma'am.
Okay, given. So now you have one angle and two sides. So which criteria will it become? Nobody will
Ma'am,
speak up now. SSA. Fine.
Yes,
So
ma'am.
by SSA, the triangles are congruent. So AOB is congruent to triangle COD. Fine. Okay.
yes, ma'am.
Now by CPCT, which angle can I write equal? Which angle is coming under triangle ABO? AOB. Angle 1. Can you see it?
Yes, ma'am.
Angle 1 is equal to angle 2. Let me just clean my figure a little bit. Then you will be able to see, I think. Just a minute. Now, this is which I called. Okay, this one was my angle 1 and this was my angle 2. I marked it like this. Fine.
Yes, ma'am.
So by CPCT, angle 1 is equal to angle 2. Now look at the line segment AB and CD. Okay, if I'm considering this, look at these two lines. Okay, and this is a transversal cutting them, and you have angle 1 and angle 2. So that means which kind of angles are equal?
Ma'am, alternate interior angle.
Alternate interior angles are equal. So what does it imply?
That, ma'am, the lines are parallel.
The lines are parallel. Very good. So by CPCT, angle 1 is equal to angle 2, and therefore AB is parallel to CD by converse of alternate angle theorem. Yes, Miraj?
Yes,
Clear?
ma'am.
Clear?
Clear.
Okay, so one side we have shown it's parallel. So AB is parallel to CD. So the next time we have to show that AD is parallel to BC. Okay, so I'm just cleaning my figure again. You don't, because I have messed it up. Okay, so now this was my angle 4 in the figure, and this 3, and this was my angle 4. So this time I have to show that this line is parallel to this line. So that means I'm going to take these two triangles this time, right? So I'll take this one and I'll take this one because I have to include angle 3 and 4, isn't it? Yes?
Yes, ma'am.
Okay. So now this time take in triangle, or you can write similarly in triangle AOB, AOD and triangle COB. Okay. Now quickly tell me whatever you have. Very quickly. Use the given condition. AO is equal to CO. Okay. DO is equal to BO. Okay. The third one. This angle is equal to this angle.
Yes, ma'am. Vertically opposite angles.
Exactly. Just give them some name S and T. So angle S is equal to angle T, vertically opposite. So therefore the two triangles are congruent. Which criteria here? SSA. So triangle AOD is congruent to triangle COB. COB. And similarly by CPCT, this time angle 3 is equal to angle 4. So far so good?
Yes, ma'am.
Any problem to anybody?
No, ma'am.
No, ma'am.
Now, please look in the figure again. So this time I'm looking at these two lines. Take this line because I have to show this to be parallel to this. So look at these two lines and just see that this is a transversal cutting them. And you have this angle is equal to this angle. So again, they are alternate angle, right?
Yes,
So
ma'am.
if the alternate angles are equal, that means the lines are parallel. So therefore, AD is parallel to BC by converse of what? Alternate angle theorem. Okay.
Yes, ma'am.
Now at last, so you have shown now AB is parallel to CD and AD is parallel to BC. We have shown, therefore ABCD is a parallelogram. Fine. So this time it was given that the diagonals bisect each other and we have proved that it is a parallelogram. Just let me know when you have written. Okay, tell me one thing. Did you have any tests so far in your maths class?
Yes, ma'am.
Okay, which chapter?
Ma'am, all the chapters revision is finished.
Okay, so the earlier ma'am took it, right? So I'm asking here, like you were learning at Learnivio. So did you have any test at Learnivio? That's what I'm asking.
Yeah, ma'am.
Which chapter you had? All the chapters.
No, ma'am.
And biology.
In maths, I'm asking. Mathematics. Was there any test so far?
I
Ma'am,
don't remember.
in variable and coordinate geometry,
Okay,
and
so
before also, like,
okay, so did you had it online? Like how you did it? You did it on a paper or what?
ma'am, she gave us some questions like on WhatsApp, and we did it, and in the class she asked us what was the answer, and we discussed it like that.
All right. So I'll also try to figure out how can I take your test in geometry. So I'll announce when we are going to have one test. Okay. I'll take a test of the chapter lines and angles. So let me see how much you guys are able to remember. Okay, done, all of you?
Yes, ma'am.
Yes, Miraj, have you done?
Yes, ma'am.
Okay. Okay, before coming to examples, I want you to write something in your copy, and this is very important. Let me just summarize all the theorems for you so that you are able to quickly revise them. So you write it like this: properties of a parallelogram. Properties of a parallelogram. You can write it complete parallelogram also. So I'm writing it short, like in a parallelogram. Now there are four things. First, diagonal divides it into two congruent triangles. Okay, this is the first theorem we have proved. Now there is a second property. Opposite sides are equal. Okay, and the third one, also it's converse. So this was the third theorem. Next. So we have seen opposite angles are also equal. And also it's converse. The fourth one is diagonals bisect each other. Also it's converse. So will you be able to remember it like this?
Yes, ma'am.
So basically the first theorem was that the diagonal divides it into two congruent triangles. The second is that the opposite sides are equal. Converse means that the opposite sides are equal and then it is a parallelogram. Fine. Now, third one, opposite angles are equal. Converse means it is given that the opposite angles are equal and therefore it is a parallelogram. Okay. Fourth, diagonals bisect each other, and it converse means that it is given that the diagonals bisect each other and therefore it is a parallelogram. Okay.
Yes, ma'am.
So like in the theorem, we show that this is the thing, that opposite sides are equal, opposite angles are equal, and diagonals bisect each other. In the converse, this thing is already given to you and we show that it is a parallelogram. Is this clear now?
Yes, ma'am.
Okay. So for these, okay, like for this part, what is given to you? That it is a parallelogram. Okay. And for this part, we prove that it is a parallelogram. Can you write it like this in your copy so that the thing becomes clear in your mind?
Yes, ma'am.
Okay, please write it exactly so that if you look at it, you will remember. Okay, I think this much is enough for the class today. In the next class, I'll start with the examples and then we will do it slowly because you people are not revising, and please revise, at least revise all the theorems of the previous chapter. So will you revise them in the next class?
Yes, ma'am.
All of you? So note down your homework I'm giving you. Okay, homework. Revise all the properties and all the theorems. Of previous chapter. So we have done chapter lines and angles and triangles. Fine.
Yes, ma'am.
Please, because those theorems will also be used in this chapter, because otherwise you will not be able to do any question. Okay. All right, then let's end the class today. And please revise. Okay, then I'm just winding up. Have you written all of you?
No, ma'am.
Okay.
Yes, ma'am. Thank you, ma'am. Good night.
Okay. Good night.
Thank you.
Okay. Bye. Good night.
Bye.
Thank you, ma'am.